I just wanted to use this video to clarify a couple quick things about classwork question 45, really just the last three parts of this question, about what happens to the other bulbs in the circuit when one of the bulbs is removed. So in part D, if bulb A is removed, like right here, and just leaves a gap in the circuit, what would happen to the other light bulbs? Well, B, C, and D still form a closed loop, but the closed loop would not allow current to flow unless it's a closed loop that includes the battery. So because there's no closed loop with the battery, since this is just a gap now, all three of these bulbs, B, C, and D, will just turn off. In part E, we're going to replace bulb A, but now we're going to take out bulb B. So we have a gap in the circuit right here, and since there's a gap in the circuit there, no current can flow down this branch, so that means bulb C will turn off. But there's still a complete loop in the circuit now that includes the battery, so bulbs A and D will stay lit. The question now is what's going to happen to the brightness? Are they going to get brighter or dimmer or stay the same? And the way to think about this is that when we take out bulb B, we're essentially taking out one of these parallel branches in the circuit because we have these two parallel branches. Parallel branches decrease the overall resistance of a circuit because there's more places for current to flow. So the more parallel branches you have, the lower the resistance of the circuit, which means the more current that can flow. So when you take out a parallel branch, like we're doing here by removing bulb B, we've taken out a parallel branch. That means we've actually increased the resistance of the circuit. And because we've increased the resistance of the whole circuit, that means less current will flow. So there's less current flowing out of the battery around the circuit, which means less current is going to flow through bulb A, so bulb A is going to get dimmer. But at the same time, even though there's less current flowing through the circuit, the fact that we got rid of this parallel branch right here, where the current was split, means that no more current can flow through here, so all of the current is now going to flow through bulb D. So that's actually going to have an increase in current despite being a little bit less current in the circuit. So bulb D will actually get a little bit brighter at the same time that bulb A gets dimmer. It is possible to figure all this stuff out by calculating the power delivered to each of these bulbs with actual numbers. Just make up some numbers, like let's say 12 volts for the battery and 3 ohms for each light bulb, and you can actually calculate the power of each of these bulbs to get the brightness, both before and after B is removed, but it's a lot of extra calculations that way. So it's better to think about this just intuitively, that less current in the circuit because of more resistance means that A will get dimmer, but more current flows through D now that that branch has been taken out, so bulb D gets brighter. And then part F, we're now going to replace bulb B, and we're going to remove bulb D. So this whole branch of the circuit is now gone. We still have a loop with the battery that contains A, B, and C in it. So none of those are going to go out. And what's going to happen to the brightness? Well, the same thing as before. Since we've taken out a branch of the circuit, a parallel branch, we've increased the overall resistance of the entire circuit, which means we've decreased the overall current in the circuit. So A is going to have less current than it had before, which means it will get dimmer, just like it did back in part E. But the same thing happens with this one, is that even though there's less current in the circuit, more current will now flow through here than before because there's no other branch for the current to flow through. So all of that current will now flow through B and C, so both B and C will get brighter.